Future World Conversations, an initiative by Future World Alliance, where we bring together builders and practitioners who are shaping the future of AI. Today's session focuses on a challenge many teams are facing as they build AI agents. While the promise of autonomous systems that can reason and act is exciting, the reality is that many agents' deployment struggle in production. One of the biggest reasons is not the model themselves, but the lack of systematic evaluation frameworks. Our speaker today, Tezan Sahu, will introduce the concept of evaluation-driven development and explain how teams can move from hopping their agents' work to actually measuring, diagnosing, and improving them. Tezan is an applied scientist at Microsoft, working on Microsoft 365 Copilot extensibility, with several years of experience building production AI systems across Bing, and Copilot platforms. We are excited to learn from his insights on building AI systems that truly work in real world. Tezan, thank you for joining us today. The stage is all yours.
Thank you so much, Padma, for the warm introduction. And yeah, super excited to be here. Grateful for the opportunity and to address this wonderful gathering here. So yeah, without further ado, let's get started. So I want folks to be honest here for a moment. How many of you have actually built or basically at least seen an agent that worked perfectly in a demo or a test prompt, and then when it was actually deployed into a real world production system, or when an actual user touched it, it just broke apart? Any experiences around that? Any show of hands if this sounds relatable? If you've tried building one or seen someone build one and experienced that as an end user? Any experiences? Okay, I do see a couple of hands. So yeah, this problem is real, and honestly, it's not a skills problem. It's not even a model problem anymore, because almost every week or every month, we are seeing significant improvements and strides in the category of models that are being showcased and launched by the top shot research and development wings of almost every big tech out there. The challenge is that we are actually shipping things on hope, and hopefully today we will try to fix that. Super quick, who am I and why you should listen to me? So hi everyone, I am Tezan. I work with Microsoft on the M365 Copilot extensibility, as Padma mentioned. I work as an applied scientist, and before this I used to work on Bing Autosuggest. So it means that if you have ever opened Bing as a search engine and have typed something into the search box and clicked anything that appeared on the pane that just appears below the search box when you start typing, most likely that completion was powered by something that my team did earlier. So you're welcome, or I'm sorry, depends on the prefix that you typed in. Beyond that, I actually graduated from IIT Bombay in 2021. So that's close to 4.5 years of experience at Microsoft now. Beyond work, I am the author of a national bestseller, which is called Beyond Code. I write an AI newsletter, which is called Low Pass Filter. And I've gotten, I've filed around 7 US patents and written a couple of research papers. But I think beyond this, most importantly, I have spent a bunch of years building and breaking AI systems at scale. And I've learned the hard way that, hey, what is the thing that actually separates AI agents that work from the AI agents that actually just seem to work? So in today's talk, we will try to start with the generic agent anatomy. We'll try to quickly understand what an AI agent is under the hood. Most of you might be familiar with it, but I'll still spend a little bit of time on this so that we are all on the same page. Once we go through that, we'll quickly look at a simple framework, which is the 5-step building process of how you can use with 5 steps or basically just think of it as a framework consisting of 5 steps with which you can go ahead and build reliable agents. And then we get to the heart of it. Once we establish what the anatomy is, what the building process is, we'll actually look at evals, the whats, the whys, the hows, why they matter, all of that. We'll look at that in the intro. We will actually go ahead then and talk about the fundamental concept of evaluation-driven development. So that's basically the mindset shift that separates good AI from great ones. And finally, I will leave you with a bunch of tools and resources that you can start using from today if you want to go ahead and build and evaluate reliable AI systems. So are we good? Are we good to start? Does this agenda look fine? Awesome. So cool. So let's start with the AI agent anatomy part of it. So before we build anything, we need to understand what we are building. An AI agent is not just a chatbot with a fancy prompt. It's basically got to do with it's a holistic system which has a lot of distinct parts, a lot of moving parts which interact with one another to to basically go ahead and give you the entire magical feel of your work being done in an autonomous or semi-autonomous fashion. So what does an AI agent typically comprise of? At the center, at its heart, is something called as the orchestrator or the conductor. Now, think of an orchestrator as something that manages the flow between the language model, the various tools, the way the way the agent interacts, reasons, thinks, or does anything. The orchestrator is something, it's basically the backbone or the heart which coordinates all these efforts. Around this orchestrator, the first important thing is something called as the instructions or the system prompt. Now, you can think of this as the agent's constitution. It defines the who of the agent, basically the persona, the capabilities, as in what the agent can do, cannot do, and what it shouldn't do. So basically, guidelines around how it should behave, what it should be doing, and who essentially the agent is. So if you're building something like a customer service agent, then you would actually give it a persona saying that, hey, you are, let's say, you are Custy, a customer service agent who is adept in solving XYZ kind of problems for the customers in this particular domain. You are well versed in English as well as XYZ languages. You basically communicate in a particular tone. You understand these things. You follow certain processes, and all of that can actually be codified into the instructions or system prompt. Now comes the LLM, which is basically the brain of the agent. Now this, as all of us know, it is the brain which understands, reasons, and decides what to do, what not to do, what the user has, based on whatever the user has entered or whatever it has done until now, it decides what is the next best step that it can take. Next comes the tools and functions. Now these are think of it as the agent's limbs. These are the ways in which an agent interacts with the real world. These could be APIs, it could be databases, it could be anything. It could be something like calculators, search engines, everything. Without tools, your LLM is definitely smart, but the only thing that it can do is just generate a bunch of text. With the capabilities that are brought in by tools and functions, the LLM gets a whole range of actions that it can perform to interact with the environment, see the changes, observe it, and react to it accordingly, and then either call more tools to complete the user's task or generate the final answers that the user actually expected. Next is something which is often overlooked a lot, but this is super critical in building reliable agents. These are called the guardrails and the safety features. Now think about it. If you ask some controversial question to the agent or something which is something related to self-harm or something that's not constitutional, you would typically want the agent to either disengage or just give you advice that you are not going in the right direction. How does the agent understand that? So in technical terms, there are a lot of different ways in which these guardrails and safety elements can be implemented. In M365 Copilot, we have a bunch of things like a lot of classifiers. We have a lot of, some of them can be instructions as well. But there's a lot of content filtering, a lot of rate limiting, a lot of error handling that needs to happen so that the responses of the agents are safe, reliable, and adhere to certain policies that the agent builder has set. Next is an optional thing, which is the output handler. For example, a lot of the agents do not directly interact with users. They might be interacting with other agents who understand a different language. For example, if an agent is communicating with another agent for a certain task, maybe English, writing passages in English may not make the most sense. It might make a lot more sense if the output is in, let's say, a JSON format or a YAML format or some kind of a structured format. So an output handler is an optional element that basically gives the agent the capability to finally produce the output in this particular format. And last but not the least is something called as the memory and the context. The memory is something which provides continuity so that the agent remembers what it is doing so far in this particular conversation, as well as what it might have done in the previous conversations or in some previous interactions with you, so that whenever you ask, you don't need to reprompt it again and again and again with the same basic stuff. So with that understanding of the anatomy of an agent, let's look at what this agent a typical agent looks like in motion. A typical user sends a message, the orchestrator picks it up and sends it to the LLM to reason about what to do next. The LLM decides that, hey, based on what the user has said, I should either select a tool. Once I select a tool, it sends that response back to the orchestrator that, hey, this is the tool that I want to select with these parameters. And the orchestrator then actually goes ahead and executes the tool, gets the results, and sends it back to the LLM for the next stage of reasoning as to, hey, I've already gotten, based on your recommendation, I executed this tool, got this result. Now what? Should I call another tool, or am I good enough to respond back to the user? If the LLM decides that the user's task has actually been done, it can get out of the loop and send the result back to the user. If not, the agent or basically the LLM decides to continue the loop and basically ask the orchestrator to call another tool which might do the next step of the task which the user might have intended earlier. Now, this if you observe this mechanism carefully, what the agent is actually doing is it is thinking, acting, observing, and then thinking again. Now, this entire thing is called the react loop or the reasoning plus acting loop. And since this is a loop which the agent or basically the LLM is deciding what to do next, this is precisely the area where many things can go wrong. The agent may pick the wrong tool. It might misread a parameter or misinterpret the user's original intent. It might go into the loop forever, thinking that, hey, there's still something more that the user might have wanted. Or it might just think that, hey, I know everything. I don't need to call a tool. I can just, based on my past knowledge, I'm good enough to give the full answer to the question. And it might end up just hallucinating the entire answer. And that is exactly why we need evals. But before going into evals, let's first talk about the building process. So we talked about the agent anatomy. Let's quickly move through the 5-step building process about how you should go about building an agent from a first principles perspective. The 5 steps, if you think about it, the first step is to define the use case. Step 2 is to basically go ahead and choose your model and tools. Step 3 is to design the interactions. Step 4 is to build the agent and integrate it into your system wherever you want to deploy it. And last, which is the 5th step, is the testing and validation step. And if I be entirely honest here, most teams that are building agents, I think even us to some extent, many of the time when we had started building and helping customers build agents, we typically spend a lot of time, more than 80 to 90% of our efforts and time in steps 4 and 5, and less than 10 minutes in overall steps 1 to 3. And the honest confession is that might not be the best way to go about things, because this is exactly why we build something, we try to ship something, and we see it break in production, because we have not defined the use case correctly, and the end users end up have a very different expectation from the agent, and they end up using it in a very different way, and that breaks the system. Or maybe we have not chosen the models and the tools based on what was the best for that particular use case, or we have not designed the interactions in the right manner which would have suited the end user in the best way possible. We just jumped the gun and started building what we thought we could build. So we'll go through each of these steps. I'll give you a quick understanding of what each of these steps entail and how you can think about it. So step 1, which is, we'll definitely spend a lot of time on the test and validate phase today. But let me quickly walk you through the overall 5 steps. So the first step is basically, it's deceptively simple. The easiest thing or the core thing that you should ask first whenever you encounter the thought that you need to build an agent is, hey, what is the actual problem that I'm trying to solve? Not the fact that, hey, we want to build an agent. That's not the use case. That's a wish. The use case that you define, or basically when you ask that question, the use case will come in a way wherein you try to understand, hey, what is exactly the thing that the end user is looking for? What is the role of AI? What are the real world constraints? A lot of the times when you start framing the problem, when you start diving into the exact use case for which you want to build a solution for, you might even end up realizing that it's not AI agent that you're looking for, but maybe the customer is actually looking for a simple automation which could be done in a much easier fashion. You can just get rid of all the so-called complexity of AI if you actually would have thought about the problem first. And this is probably the most overlooked step, but this is probably the step which yields the most value and significantly reduces the cycle time of building and testing your agents. Along with problem framing in this particular phase itself, it is absolutely critical to understand what success looks like, not just technically, but for the user also, for the business, for compliance. What exactly does success looks like? What are the outcomes that you would consider the agent to be successful if it was able to achieve? Are there beyond the functional elements, are there other things like security, RAI, responsible AI, all of that? It shouldn't just be a checkbox in the end for you. It should be baked into the design from day one. And that is exactly what happens when you start thinking about the problem and the success metrics both during the first stage of building. The next stage, at this point, once you have a grip on what the actual use case is, what's the kind of problem that you're trying to solve, and what does success look like for you in that case, you're probably at a good point to say that, hey, now given this use case, what are the most appropriate models or tools that I can actually use? So the first and the foremost thing is that it's super important to align with the organizational standards. Now, if you're building for an organization or if you're building within certain frameworks, what are the models and tools that are approved for being used within that ecosystem? Then you basically choose the right model for the job. Do you need a general purpose language model, or would a smaller model do? Do you actually need that cutting edge GPT 5.2 model for all the answers that your agent is giving, or can you actually trade it off for simpler questions being answered by a potentially smaller model, maybe GPT 4.0 or GPT 5 Nano? Which could be much cheaper, but can actually address, let's say, 80% of your customers' queries. That's the kind of decisions you take place when you're trying to choose the models and tools. Then consider whether agents are actually necessary. Agents become necessary when you are actually orchestrating multiple steps. As I mentioned, when you start defining the problem in the first step, you are in a position to understand what is the degree to which AI is actually needed. Sometimes you may the use case is complex enough that you may need agents to support it. But sometimes for certain use cases, you may not even need an agent. It could just be a simple RAG system. It could simply be an LLM connected to a vector database and a simple RAG system to help you answer help desk kind of questions. You may not need an agent for that. So this is again something which can come up during the discussions that happen during step 2. Next, if you are accessing any internal systems or APIs or MCP tools that are offered, I think it's always a great idea to understand what are the tools available at your disposal, how secure they are, and whether using any of them needs some kind of external audits that need to be done, especially if you're working on enterprise-related scenarios. And last but not the least, the key question that you should always ask is that, hey, are we over-engineering this? Because often we realize that simplicity leads to better performance, easier maintenance, and faster iterations. So while choosing your models and tools, always ask this question and understand the right balance between the right set of trade-offs that you need to make. With that, we have chosen our models, we have chosen our tools. Now let's focus on what the exact user wants and how the user might want to interact with the AI. This is exactly the point when you start with the prompt design. Now, this is your primary lever for shaping the model behavior. You need to be clear, structured prompts that lead to more predictable outputs. Next, we've all been hearing a lot that, hey, prompt engineering is dead. Context engineering is something that is coming out. So yes, context is super important for any agent to work well. This is exactly when you're trying to design the interactions for the agent. This is exactly where you understand, hey, what is the right way? What are the right places? What is the kind of context that I want to inject? Do I need to always inject all the tool results? Do I need to inject, or do I need to inject certain filtered fields from the tool results whenever a tool is called? Should I be recalling, let's say, 20 elements from the memory or just one element from the memory? Should I even use memory? Or what are the details of the user that I should be using in context? Should I be using any past conversations? All of that, thinking about all of these things, it comes under this aspect of what you need to inject into the context of the agent for it to behave well. Next, you basically understand that grounding as a concept is key. Now, what does grounding mean? When you are connecting your model when you're connecting an LLM to a tool through the orchestrator, you would always want that whenever the LLM starts using the tool's results in its response to construct its final response, how would the end user know that it has actually used a tool response unless the agent actually states explicitly that it has used the result? And the clearest way of stating this is by providing something like a citation. Most of you might have seen that in results provided by Copilot or ChatGPT or Gemini, you will see those small boxes with 1, 2, 3 written. If you hover on them, you can get to the links of the actual web pages or the actual data sources from where the data came from that helped in the creation of the final answer. That is what grounding is all about. That's what providing citations is all about. And having grounded responses allows the agent to be super trusted by the users. Now, what is the level of grounding that's needed? Should we be showing citations? Should we not be showing citations? Now, if you realize for a lot of the things that ChatGPT does, if it actually uses web search results, it actually shows them as citations. But let's say if you have ever played with connectors in ChatGPT, even if it has called a connector, it will not cite the connector result. That's a design decision that they have taken, that they have thought about during this particular phase. OpenAI has its own reasons for doing what it does and not doing what it doesn't. And again, this is a step where you try to apply as many, think about the pre and post guardrails for safety, reliability, RAI, all of these things. This is exactly the place where you think about what does bad output mean? What are the kinds of scenarios or kinds of situations wherein the agent should disengage, or how should the agent respond if there was an internal tool error? or there was maybe the user asked a question which involved multiple tool calls, multiple steps. Some things were done right, and then suddenly there was a network blip, or a certain tool did not return a result that was expected or useful. How does the agent respond in those situations? These are the kind of thoughts and decisions that you need to take before you actually go ahead and start building the agent. Now, with steps 1, 2, and 3 out of your way, this is exactly the place where you start moving from the thinking and the design to the actual execution. Now you are actually building the feature or the AI agent. You start developing using the models, the tools, the connectors that you've actually selected, and you make sure that you're working within, of course, your organization's approved platforms. Now, all of these things, if you see, you've actually gotten a good grip on these things during the step 2 itself. So building becomes much easier, much faster, with lesser iterations and lesser back and forth between your compliance teams, your RAI teams, all those checkboxes that you might have. You might need post hoc. They are all taken care of in the previous thought or design steps itself. You definitely it's definitely critical to meet all the requirements, be it functional, be it the RAI, be it safety, be it compliance. All of that is super critical, and these are some things that you bake into your agent right from the right from the first stage of building. So it becomes second nature to just include all of them while building. And lastly, you always return to the fundamentals, things like your version control, testing, documentation, performance benchmarks, how the agent is doing on latency, on quality, all of that. These are all standard development practices and non-functional requirements, which we might have all seen in a lot of software development practices. They all directly translate into the building phase of your AI agent as well. So software engineering is not going anywhere. It is just transforming into something called as AI engineering. And with that, we reach the final step, where we are making sure that the feature performs exactly as expected, and it does so responsibly. So we start with testing. We explore the edge cases. We run bias tests. We basically ensure that we are testing across a diverse range of scenarios. I will talk about how you can actually come up with these diverse set of scenarios in one of the next future slides as well. And so, yeah, robustness and quality is super, super critical whenever you are doing the testing. Now, in traditional software development, you might think about this thing as the unit testing, the functional testing, the integration testing part of things. So all of those things can actually translate very well to the various deterministic components of your AI agent. The only addition that you would want to do for agents is something called as validation, because there's a lot of non-determinism that is brought in by the LLM, which, as we all know, even if it's given the same input, it might just give different outputs in different runs. So typically in validation, we are measuring the performance metrics, the latency, the cost, the expectations, whether the agent is actually doing end-to-end what we expect it to do, whether it's maintaining the quality, maintaining the safety standards, or is it going off in any particular ways. And lastly, once we have done the tests, we validate it, perhaps we deploy it, we continue testing and validating. After that comes the step of optimization. Now, this may have started earlier. You might have been optimizing on the models and the tools in step 2 itself after the selection. But this is exactly where you revisit those choices, you revisit those decisions, and based on the results of your tests and validations, or perhaps things that you've seen after the agent has been deployed, you figure out what's the best way to tune your agent, the various components of the agent, so that it starts performing even better or achieves even better scores on the benchmarks and the tests that you have set during the testing and the validation. Now, before we move to the next section, any questions? Maybe I can take one question or so, if anyone has. Else I'll proceed. Well, if not, then cool. I think we completed the first two things, and I hope we are all geared up to just quickly understand about what exactly evals are, which is basically the meat of this talk. So think about it. If, as I mentioned, I think I gave the scenario earlier as well, that if an AI agent seems to work on just a test prompt or just in a demo scenario, is it sufficient to conclude that the agent works fine? Most of you said that you wouldn't. You more often than not, you've actually seen agents work once but fail on other instances. Now, why does that happen? We'll try to understand that to understand why evaluations and setting up this concept of evals and eval-driven development is so critical. Let me show that to you in a very systematic fashion. So let's talk about some of the core challenges of building these AI agents. And honestly, I'll talk about 4 of them, and I have spent tons of time battling each one of them at a personal level. So this slide is very personal to me, and I hope you will also be able to relate to it in some way or the other. The first biggest challenge is the fact that AI and LLMs are non-deterministic. Your agent definitely gives you different answers to the same question every single time. And if you try to do something like unit testing, wherein you are trying to assert a particular syntactic element that, hey, this should contain this, or this is equal to something, then definitely you will not get your asserts are doomed to fail if you are doing it in a deterministic fashion. So I think all of us have experienced that with Copilot, with ChatGPT. But yeah, non-determinism is the biggest and probably the heart of all the challenges of building any kind of product with AI. Second is the fact that correctness is not guaranteed. Your agent doesn't just answer since it's a little non-deterministic. It sometimes may not answer things correctly. It will definitely answer things in a confident fashion, but it might end up answering things in a confident but incorrect answer. A lot of the times you might see that, hey, if I ask. Think about the earlier models, which maybe in 2023, 2024, when you ask it real world question that, hey, what was the test match score yesterday, or when is the first match of IPL supposed to be scheduled in India? It might just use its past knowledge and retrieve and tell me something about the year 2023 or 2024, not the recent thing. It might just come up with something plausible, but might have totally hallucinated that. So yes, correctness is not always guaranteed. And the third one, I think, which is my personal favorite, is the whack-a-mole effect, which is basically you try to fix one problem, you end up with another problem. And for example, let's say this is a personal example. We had a customer who had been complaining about their agent hallucinating a lot. We tried to do some fixes in the instructions. We fixed the hallucination problem, but congratulations, we ensured that the agent is so paranoid that it doesn't even commit to the action. It doesn't call any tools. Now we fix that and something else breaks. Now every improvement that you do may end up destabilizing something else in the system, because it's a huge complex system with a lot of moving parts, as you might have noticed in the anatomical section that we talked about. So yeah, the whack-a-mole effect is real, and it's one of the most painful and sometimes the most interesting part of building an agent as well. And due to all of this, the traditional unit testing, functional testing kind of frameworks fall short, and we need something more, which is beyond the norm of basic software testing. And that is exactly why evals are not optional. They are survival for building an AI agent. The reason why agents evaluation is so critical, let's talk about it from two angles. First is the business reason. The thing is that if you start evaluating agents before production, you tend to catch issues early on, which definitely means that the buggy agent doesn't ship to production. Your reputation of your company, the reputation of your product, all of that stays intact. Good business value. When you're building the agent, if you keep on iteratively evaluating and measuring what you're building, you definitely go ahead and are able to measure the incremental improvements that you're doing with every change. And the moment you also continue to evaluate and evaluate after the deployment of your agent, you are definitely monitoring the quality. You are cognizant of whenever there are any dips in the quality, or if there is a certain drift in any of the metrics, you can understand and almost in near real time, at least figure out that there is some issue and work towards fixing or improving the agent. From a technical standpoint, evaluation helps a lot because honestly, we as humans are also very much attuned to get objective things compared to get objective results or objective metrics compared to subjective feelings. I think many of you might have, I think in your aptitude tests or any kind of competitive exams that you might have given in the past, how many of us have actually loved to write essays kind of questions versus how many of us have actually liked to answer the simple true false or MCQ kind of questions? Most of us would answer the fact that, hey, we like those objective kind of questions. They are easy to do, easy to understand, easy to work with, compared to those long answer essay type questions, which may or may not fetch you the full marks, even if you have done a damn good job. Similarly, if I just receive a very vague thing that this particular agent is doing good on is doing good on XYZ task, may not be doing that good on this on some other tasks, I have a subjective sense of what it might be doing well, but I cannot objectively quantify. Hey, okay, this is where I am at today, and this is where I want to go, where I want to reach, or where I want my agent to reach. So it's difficult to compare if the new model that I'm trying out, whether it's actually substantially better than the one that I've been using so far. Is the orchestration mechanism that I am trying out now, is it actually much better than the previous one, or is it regressing certain things, or is it just as par? So since it's too costly, I might not want to go ahead with that. So these are technical decisions that are hurt a lot if you have a lot of subjectivity involved. Evals help turning those subjective thoughts and decisions into objective metrics, which can be used for a lot of comparison and a lot of regression detection. So the bottom line is we all have heard the maxim that, hey, you can't improve what you don't measure. And this is exactly why evaluations become such a critical aspect of agent development. Today, evals is perhaps the most important skill that anyone in your team might want to have. So yeah, we understand why evals are critical. Now let's look at what to do or what do we even want to evaluate. Now there are 5 typical dimensions in any AI agent that should actually be evaluated. First is the task success. Agents are meant to do certain tasks. So when they are given the task, did they actually do the task what the user asked end to end? Not just did it respond or did it just solve the problem? End to end, if the user had given a task which involved multiple steps, did the agent actually successfully do the task? This is a yes, no. This is a pure yes, no, true, false kind of thing. It's a binary answer that you get for such kind of for this particular dimension. Second is the process quality. The agent might have done the task. It might have completed a particular task, but did it do it in the right way? Did it actually follow all the steps? Did it do the reasoning correctly? Did it pick the right tools? Did it pick the right tools in the right sequence without hallucinating? Now, all of those answers can be given if you have visibility into the agent's entire trace and you are able to evaluate the overall process quality that the agent followed while it was able to achieve a particular task. The third thing is reliability. What happens when things go wrong? Does the agent retry gracefully? Does it handle ambiguity? Does it fail safely? All of these questions can be answered using the reliability dimension. The fourth and a very critical dimension, which we often again overlook, is the safety and compliance part. Was the output safe enough for use? Is it allowed? Does it align with the organization's policy? Does it align with your brand voice? Especially super critical in any kind of enterprise contexts. And last but not the least, the efficiency angle. How much did the agent actually cost? How much did running the agent actually cost me in terms of tokens, in terms of time, in terms of money? How many tool calls did it burn? How many tokens did it burn? Because technically in production, the fact that an agent works is just half the thing. But when an organization or an enterprise is deploying certain agent for the user, of course, the users are paying money to use it. And if the money that the users are paying is less less than the kind of costs that you are incurring in running the agent, you will definitely not be a profitable organization. So these are the 5 dimensions, and all of them matter. And while some might seem, but none of them are.
So we understood why we need evals and what exactly we should be evaluating for AI agents. Now, how do you actually go ahead and evaluate these dimensions? There are practically 2 approaches which you can go ahead with. The first one is called the rule-based evaluators. Now, think of these as programmatic checks. Stuff like, what does the response even contain? Does it contain a specific keyword? Does it contain a pattern? Does it have a particular format? For example, if you want your agent to produce a tweet, tweets are usually need to be under a particular character length. Now, whether the agent's response is within that character length. Now, all of these, they are fairly deterministic to be computed and can be easily done using by writing some sort of programs, or could be conditions, could be loops, could be simple functions, because they're perfect for formatting, format, structure, and specific patterns. The second thing, which is new or very different as far as evaluating the non-determinism of agents is concerned, that technique is called LLM as a judge-based evaluators. Now, here's where you use another language model to evaluate the outputs of the AI agent. Is the response relevant? Is it coherent? Is it helpful? These are nuanced qualitative dimensions that are hard to explain as rules when written in code. However, they can be easily expressed in natural language, which an LLM can actually understand. It's surprisingly easy to explain that to an LLM, and hence this is using an LLM could be a great way to convert all these subjective judgments into an objective metric that we were looking at. The only downside is that since you're running an LLM, you will of course incur costs, and it will be relatively slower compared to a rule-based evaluators. So the best practice that I would suggest, use a good conjunction of both kinds of evaluation techniques, because you can actually use these rule-based techniques for a lot of these precision checks, and the LLM-based metrics for the quality and the nuances that you may want to evaluate. So yeah, I think having both these kind of evaluation metrics baked into your suite should be a really good practice. Now let me introduce you to the different worlds of evaluation, or basically how does evaluation actually take place in the real world? Or how do production teams in production actually go about evaluating AI agents or any AI product for that matter? First thing is called offline evals. Now, consider this as your lab. This is basically comprising of all controlled data sets, replay scenarios, trying to get as much reproducible results as much as possible. Typically, you would run these before you ship agents. Now, this is your safety net. This is exactly where you would want to catch more than 80% of your issues before the real users actually see them. So that's why you should always start here. The next is online evals. Now, this is when you have deployed your agent into actual production and you actually have real user traffic, real inputs, and real consequences. You're actually measuring the true real impact. This can be done through A/B testing, telemetry, user feedback, bunch of these signals. The only downside is that, of course, there are privacy constraints and there is limited visibility. And beyond that, LLM as a judge doesn't scale to online evals because it has a lot of cost as well as a lot of latency involved. Now, while both of these are at the two extreme ends, there's something which is very interesting and stays right in the middle, trying to bring in the best of both worlds. And this is called shadow evals. It tries to bring the best of both worlds. And honestly, it's my favorite. And I've personally been using this a lot, and I've been working on this a lot as well. Here's how it works. You basically go ahead and try to fork the real traffic into two streams. One stream actually goes into the production system that is currently deployed, while the other one is the one which goes into internally after the fork. It actually goes into the system that you might be testing, the new system that you might be testing. This could be a newer model, newer orchestration, extra tools, anything that you are thinking about. The catch is that the user ends up seeing only the results from the first stream. But you as a developer would log the results and the entire life cycle of both the streams, and you basically would go ahead and measure both. You get the real world inputs as well as the goodness of the offline measurement of both the streams, so that you can actually go ahead and compare with real world inputs as to how your current system is behaving and how your new system might be behaving. So the playbook is that you start with offline evals, you ship, you add online evals, and for any major change, you kind of try to use shadow evals of sorts wherever possible before fully flighting any change. So yeah, I think that's the key. There's offline and online at both ends of the spectrum, and shadow evals, which is basically which currently is a very active area of research and development from a technical standpoint. I think with that, we've covered a good amount of ground. We've covered a bunch of things around the agent anatomy, the building process, spent a good amount of time talking about evals and the fundamentals of evals. Now that sets the stage to talk about something which is the evaluation-driven development. Now, what does EDD or evaluation-driven development stand for? EDD is nothing but the AI equivalent of test-driven development, which is one of the most used frameworks for building and testing general software products, and it is just as powerful. So here's the loop. You start building with a representative test data set, not just the happy parts, but consider a data set which actually would incorporate your nuances, your edge cases, ambiguities, known modes of failure, all of that. Once you start building with that, you create agent variants or different these variants could be variations in model, variations in orchestration, variations in anything that you want to test, any experiments that you might want to do, so that you think that, okay, changing this piece or this component of the agent might actually make it work better. Something of that sort. It could be even change in system prompts as well. So once you create these, you actually apply these multiple evaluators that we talked about in the past. Accuracy, coherence, safety, efficiency, whatever suits your use case. You want to try to apply those evaluators, and you want to create a dashboard out of all the eval metrics, not just a single number, because a single number doesn't tell you the entire story. Now, once you get all these evaluations done for these various these variants, you go ahead, analyze them, try to find patterns, and figure out the key actionable insights behind the patterns. And using that, you iterate. Using the insights gain, you now have concrete evidence as to, hey, which of these things which of the variants is actually performing better, why it is performing better. Could it be, how can it be improved? What are the current failing scenarios? All of that you are figuring out through these iterations, and you are trying to build the next version and and you're trying to iterate on it in a much more systematic and data backed manner, not just using your intuition. Now, the golden rule here is that you basically save every tricky case that you encounter. Now that becomes your golden set. Now you run it in every single iteration, and that becomes the entire thing becomes a regression suite for your entire AI agent. Now teams who do that improve systematically, and teams that don't, they are, as you know, they are playing whack-a-mole forever. So we talked about the importance of creating a data set or a golden data set or a test data set that we mentioned. Now, it'll be a very big understatement if I say that your evaluation is only as good as your test data set. Because regardless of anything else, the data set on which you are evaluating your agent or testing your agent, that becomes the heart and soul of evals. So we'll spend a couple of minutes discussing what does it take to design a good data set. Because we all know the garbage in, we all know the maxim of computer science: garbage in, garbage out. And if your test data set doesn't contain real world scenarios or real world expectations of your users, your evaluations will not yield any results. So what does a well-designed data set mean? The key principles behind it is that the first thing, definitely, it should reflect the real distribution of users, user inputs, not just the ones that you might have thought of in your initial planning. How do you get these? You basically talk to your customers. This is exactly where the phases 1 and 2 of your entire 5-step building process comes very much in handy. You try to cover as many scenarios as possible, easy, medium, hard, represent all kinds of user intents, as many as possible that you're able to get. Define clear success criteria. You basically should be defining what, since you will be evaluating on particular on those 5 different pivots or dimensions that we talked about, you need to establish what the clear success criteria actually looks like. Because unless you have the ground truths or the expected values for the queries that you have added into your data set, what the end user might be expecting, anything that your agent responds, you will be flying blind if you don't have anything to compare it against. Your data set must be diverse. It should, as I mentioned, it should cover happy paths, edge cases, ambiguous queries, hostile inputs, multilingual inputs, domain-specific terminology. All of that should be considered. And it should be balanced, as I mentioned, it should be balanced across all the dimensions. As it grows, every time you discover a new mode of failure in production, you would want to add them into your data set. Your test suite actually grows with the number of iterations that you do, the number of times you build, deploy, monitor. And yeah, you should actually think of your test data set as a living document that actually encodes everything that you have learned about how your agent can fail, so that you are in a position to always ensure that, okay, any changes that I'm doing, how much is it able to improve on the existing scenarios that were earlier failing. Now let's quickly talk about some of the metrics and some of the critical ones that are especially important for state-changing agents. Now, what does state-changing agents? State-changing agents are those agents which don't just read data and give you information, but they are actually capable of performing tasks, doing things, interacting with the real world, and changing the state of the real world. Especially in state-changing agents, task success rate, which is basically the percentage of end-to-end tasks that were completed, that is usually your headline number. And then when you start delving into the dimension of process correctness, then you start looking at other metrics like tool correctness, relevance, maybe on a scale of 0 to 10, how relevant the result was for the user, or something of that sort. Yeah. And there are dozens of other metrics that you can actually look at based on the dimensions and the most critical things that you want to evaluate for your agents. But the insight that most people miss, especially when you're designing metrics, is that the scores alone are not sufficient to become actionable insights. Something like the task success rate is 72%. Now, that as a framing will tell you nothing without understanding what the rationale behind it is. Where did the 28% fail? What are the patterns that they share? What does failure actually look like? Unless you have those rationales built in, you won't be able to make sense of the metrics. And that is why one of the key principles, whenever you're trying to design any of the, specifically the LLM based metrics, it's always super critical to ask the agent to, whenever it's you're asking to give it a pass fail or a score out of a range, it's always a great idea to ask the agent to also give us a written rationale about why it's particularly trying to give that score. So, because rationales are the way to explain your failure modes and your edge cases, and without these, the story cannot be made complete. So, yeah, always ensure that you capture both the numbers as well as the rationales. And now that you have your eval results, what do you do with that? This is exactly where your data goes ahead and becomes the backing behind your decisions. So step one is to identify patterns, not just the outliers. One agent that picked the wrong tool perhaps is noise, but let's say if the agent has been doing that for 10 times for 10 different inputs or a certain specific subdomain of inputs, then that's a clear signal. Some key patterns that you can actually watch out for is, let's say, consistent wrong tool selection, premature execution of particular action, overthinking, continuing the loops unnecessarily, or missing certain constraints repeatedly. These can be important patterns that you can identify once you have your eval set in place. Step two is to basically go ahead and map these various failure modes to the kind of fixes. Now here in the deck, I have actually shared some very common failure modes and some very common reasoning behind why that might be happening and what could be some quick fixes. I won't go through this in detail, but I will allow the readers or the viewers to basically look at this, take a moment to consume this and understand that, hey, okay, these are some very common modes of failures. And what can be done? What are the typical industry standard things that can be done to fix those failure modes at scale? Now, it's always a great idea once you have these mapping, once you have the exact patterns, once you have the mapping done. Now it's up to you to go ahead and prioritize the high impact fixes, because not everything can and needs to be fixed all at once. Triage it like a doctor, like what's life threatening and what can wait. This is exactly what engineering is all about. Engineering AI systems is all about becoming data informed, systematic, and that's super satisfying. So yeah, that brings me to the most compelling reason to actually invest in evals. Now, because without a strong eval set, your building cycles will become weeks of iteration, your confidence is low, and you are always just shipping and praying. But with strong evals, your cycle time reduces from weeks to perhaps hours or days, and you ship with high confidence, and you exactly know what the agent is capable of doing and where it might falter. And that's exactly why teams which have a very robust eval pipeline ship almost 10 times faster, because they can learn 10 times faster. This is not an exaggeration. I've seen this happen firsthand multiple number of times. And the teams that have a very solid eval infrastructure seem to be moving slower at first, though, because there's an initial cost associated with building the data sets, thinking about the metrics, setting the flywheel up. But once that's done, they are suddenly lapping everyone else. So with that, let me share some very quick head starts about where you can get started with all of these, implementing all of these whenever you need them in practice. So for end-to-end evaluations, there are a bunch of tools that allow you to build data sets, run evals, and compare a lot of variants. So you can think if you're building on Microsoft related stack, then definitely use Azure AI Evaluation SDK. It has deep Copilot integrations built with a lot of various kinds of off-the-shelf evaluators available. Beyond that, there are a bunch of open source variants available, which include PromptFoo, BrainTrust, there's Langsmith. BCG Art Kit specifically for a lot of the regulated industries for fairness and safety evaluations. Uh, if you actually want to use simply the LLM as a judge-based evals, you want to play around with it, then LangChain has a very good, very interesting thing called as open evals and agent evals, which are flexible, composable judges that you can actually plug and play into any pipeline. There's Ragas, which is purpose built for RAG evaluation, retrieval augmented generation kind of evaluations. It's super essential. The various different tools are for different jobs, so you can try to mix and match based on your the ease and your utility. Then, if you're looking for observability and monitoring, like what the agent is actually doing in production, things like LangFuse, Helicone, Arise Phoenix, Comet OPIC, all of these are super excellent. They can actually trace all your LLM calls, all your tool invocations, token usage, latency, all of them. So the pro tip here that I would want to leave you with is that don't just try to instrument everything from day one. Start building the offline evals using tools like PromptFoo or BrainTrust, and get to your baseline as soon as possible, ship, and then add the observability as you scale. Layer the monitoring, layer what you want to learn and what you want to monitor and observe for. So that kind of a mindset really helps. So yeah, with that, let's just recap some of the key takeaways that I want to leave you folks with. First is that if you want to remember just one thing out of this entire talk, just remember eval's velocity is equal to your product velocity. Because the team who ships faster are actually the teams who are measuring the fastest. And this is not coincidence. Second, hope is definitely not a strategy. Measurement is. If you can't measure it, you cannot improve it. And if you cannot improve it, you can't ship it. You might be able to ship it, but you can't ship it confidently. Then, of course, start small and scale systematically. Even if you have 10 to 20 representative samples in your query set, go ahead, use that to evaluate. Use that, gain confidence, ship your first version, figure out what are the edge cases, where is the agent faltering, try to pull all of that back into your eval set and let the eval set grow as you are growing with your agent. Fourth, combine your evaluation approaches. We discussed what the difference between rule-based and LLM as a judge-based evals for different kinds of dimensions and metrics that you can implement. So yes, mix and match. There's no one-size-fits-all solution for everyone. And lastly, design for the real world, because test datasets that are not hard are not really helpful for your agent. If you're just having easy examples that, hey, that agent is always passing, then sorry, you have not built a test set. So yeah, if you want to remember one thing from today, then yeah, let this be it. Your users don't test the happy path. Your evals should definitely reflect that. And with that, that was all from my side. Hope this was helpful for the audience. And yeah, I hope you I hope that after this talk, whenever you are planning to build agents, you truly stop hoping and start evaluating so that you have really reliable and awesome agents in production that scale really well. Thank you.